Why can we sometimes smell rain before a single drop touches the ground? Think about it. You're walking on a hot summer day, the sky darkens, and suddenly the air is filled with a sharp, earthy, almost metallic fragrance. It's so distinct that people call it the smell of rain. But here's the twist. That smell often arrives before the rain itself. How is that possible? Is rain somehow broadcasting its arrival through the air? Or is our brain playing tricks on us? Today we're going to break this mystery apart piece by piece until it makes complete sense. And I promise by the end, you'll never experience that smell the same way again. Let's start with the strange fact. Rain doesn't actually have a smell. Water itself is odorless. If you filled a glass with pure distilled water and sniffed it, you'd smell nothing. So why does the world suddenly acquire this earthy, nostalgic perfume right before a storm? To answer that, we need to step back and look at the ground beneath our feet. The key isn't in the raindrops, it's in the soil. There's a word scientists use for this scent, petrichor. It comes from Greek roots meaning stone and the blood of the gods, a poetic name for a very down-to-earth chemical process. Petrichor is produced by certain organic molecules in the soil, mainly from bacteria. These bacteria, called actinobacteria, live in dirt and break down organic material like dead plants. When they do this, they release a compound called geosmin. Geosmin is the real culprit behind that earthy fragrance. Here's the fascinating part. Humans are ridiculously sensitive to geosmin. You can detect it at concentrations as low as 5 parts per trillion. That's like sensing a single drop of dye in a swimming pool the size of an Olympic stadium. In fact, our noses are so good at picking it up that it might even be an evolutionary adaptation. Some scientists believe our ancestors used this sensitivity to track down fresh water sources in dry environments, because the smell of wet soil hinted that rain had fallen nearby. But this raises a question. If geosmin is already in the soil, why don't we smell it all the time? Why does it suddenly hit us only before or during rain? To understand that, let's use a simple analogy. Imagine geosmin molecules as tiny letters sealed in envelopes. Normally, they stay locked away in the soil. You can't read them and you can't smell them. But when rain begins to fall, those raindrops crash into the ground like hammers. They hit the soil and create microscopic air bubbles. These bubbles rise up and burst, releasing tiny puffs of geosmin into the air. Suddenly, the sealed envelopes are ripped open and our noses start reading the letters. This explains why we smell petrichor during rain. But what about before? How can the smell arrive minutes or even hours before the first drops touch the ground? The answer involves another invisible player, the wind. Ahead of a storm, powerful downdrafts push air from high up in the clouds down toward the ground. This moving air stirs up dust, pollen, and yes, geosmin molecules that were lingering in dry soil. These compounds get carried into your nose before any rain has a chance to fall. It's almost like the storm is sending out a scented calling card, warning you that water is on the way. But geosmin isn't the whole story. There's another component of the rain smell that people often overlook, and that's ozone. Normally, ozone hangs out high in the atmosphere far above our heads. But during a thunderstorm, lightning rips apart oxygen molecules, creating small amounts of ozone. Strong storm winds can drag some of this ozone down to the surface. Ozone has a sharp metallic smell. Some describe it as similar to chlorine or freshly cut grass. When it mixes with geosmin, it creates that complex layered aroma we call the smell of rain. So, in reality, when you sniff that scent, you're smelling a cocktail of molecules. Geosmin from bacteria in the soil, plant oils released after long dry periods, ozone formed by lightning and carried by storm winds. It's nature's own perfume brewed in the clash between earth and sky. Think about how elegant this is. Our brain interprets these molecules not just as odors, but as signals. They tell us about the state of the environment around us. Long before weather forecasts or radar, our ancestors could step outside, sniff the air, and predict with surprising accuracy that rain was coming. The smell of rain is, in a way, an ancient weather app written into our noses. And the magic doesn't stop there. Scientists discovered that raindrops don't just splash geosmin into the air randomly. They actually form aerosols, tiny airborne droplets filled with trapped soil particles and compounds. High-speed camera experiments showed that when a raindrop hits a porous surface like dry soil, it traps air beneath it, then shoots that air upward in a tiny fountain of bubbles. Each bursting bubble sprays an invisible mist into the atmosphere, loaded with geosmin molecules. This mist can travel surprisingly far on the wind, delivering the smell of rain to people who might still be miles away from the actual storm. If you've ever been surprised by how strong the smell is after the very first drops of rain, Now you know why. It's not about volume. It's about efficiency. Those first drops hitting bone-dry ground release the biggest bursts of aerosols. After the soil becomes saturated, the effect diminishes. That's why the smell is most intense at the beginning of a storm and fades as the rain continues. It's worth noting that plants also contribute their own role in this story. During dry periods, some plants release oils that coat soil and rocks. When rain hits, these oils dissolve and combine with geosmin, enhancing the smell. That's why in some regions, especially deserts, the scent of rain can be uniquely strong and sweet. For people living there, this smell is more than pleasant. It's a signal of survival. It tells them that water, life's most precious resource, is finally returning. So let's recap where we are on this journey. We started with a mystery. Why does rain have a smell? And why do we sometimes sense it before it falls? We learned that the smell isn't from the water itself, but from geosmin, a compound made by soil bacteria. We discovered that raindrops hitting the ground release these molecules into the air through bubbles and aerosols. And we uncovered how winds ahead of a storm, along with ozone from lightning, bring this smell to us even before a drop hits the ground. In short, the smell of rain is the combined language of earth, plants, bacteria, and sky, translated into a fragrance our brains can understand. But there's still one last layer to peel back. Why does this smell feel so powerful emotionally? Why does it trigger nostalgia, comfort, or even goosebumps? That's where psychology meets biology. Our olfactory system, the part of the brain that processes smell, is wired directly to the limbic system, the area that controls memory and emotion. Unlike sight or hearing, which pass through more filters, smell takes the express lane to our emotional core. That means when we sense petrichor, we don't just process a chemical, we feel it. It brings back memories of childhood summers, of running outside barefoot during a storm, of standing on a porch with family as thunder rumbled. The smell of rain is a time machine powered by molecules. And here's the kicker. Even if you've never thought about geosmin, ozone, or aerosols, your brain has already been trained to interpret this smell as a signal of change. It whispers to you, something's coming, get ready. That's why the smell of rain is almost universally recognized and loved. It's not just about chemistry, it's about anticipation, survival, and the deep connection between humans and the natural cycles of our planet. Now, in the next stretch, we'll push this discovery to its final Eureka moment. Because understanding why rain has a smell isn't just a fun fact. It changes the way you see storms, soil, and even your own brain. It reveals how life has evolved not just to survive in the environment, but to sense and interpret it in ways so subtle they feel like magic. And as we uncover the final pieces, you'll see how this hidden communication between earth and sky shapes our world in ways you never imagined. Here's where everything comes together into a bigger picture. What seems at first like a simple curiosity, the smell before rain, turns out to be a perfect example of how deeply connected we are to the invisible chemistry of our planet. It's not just geosmin or ozone or aerosols. It's the way those pieces fit together into a communication system between the ground, the air, and us. It's a hidden dialogue happening every time the weather shifts. And once you understand it, you start to notice that rain smell isn't just a background detail. It's a signal in a living system, one that your body has been trained to read over millions of years. Imagine for a moment that you're living thousands of years ago, long before cities, before technology, before weather apps. You're walking across a dry savanna. The plants around you are brittle. Your lips are cracked from thirst. Suddenly, the wind shifts and you catch that earthy metallic note in the air. Instantly, your brain lights up. Water is coming. Shelter, life, and survival are near. This isn't just poetic, it's practical biology. Our sense of smell evolved to catch these environmental clues. And the smell of rain might be one of the oldest and most reliable signals in human history. Now let's look at another twist. Not every animal interprets geosmin the way we do. In fact, some species are actively repelled by it. Studies show that certain insects avoid geosmin because it can signal the presence of harmful microbes. For them, it's a warning label. Stay away from this soil. It's dangerous. For us, though, it became a positive cue. Same molecule, different meaning depending on what a species needs to survive. This is nature's version of context. One chemical can be both a red flag and a welcome mat, depending on who's smelling it. Isn't that incredible? And think about how this scales up. Every storm is a kind of chemical orchestra. Lightning is striking, splitting oxygen, making ozone. Plants are releasing oils after long periods of drought. Soil bacteria are producing geosmin in their endless cycle of breaking down organic matter. And raindrops are the percussion section, beating against the earth and sending those molecules upward. When you inhale before a storm, you are literally breathing in the combined song of earth and atmosphere. It's also worth realizing how rare and precious this is. If you lived on another planet, the smell of rain might not exist at all. On Mars, for example, the thin atmosphere and cold soil mean there's no rain smell waiting to burst from the ground. On Venus, the clouds are made of sulfuric acid, definitely not a perfume you'd want to sniff. Even on giant planets like Jupiter, with their wild storms, the chemistry is so different that the smell of rain wouldn't resemble anything familiar. What we experience here on Earth is unique to the recipe of soil, water, and life that evolved together. The smell of rain is a signature of a living planet. Now let's shift to a more personal perspective. Next time you sense that fragrance in the air, try pausing for a moment. Close your eyes and realize that your brain is decoding molecules that were once buried in the soil, released by bacteria you can't see, lifted by winds you can't feel, and shaped by lightning miles away. It's a chain of events spanning earth and sky, all delivered in a single breath. That realization transforms a routine walk into something extraordinary. And here's the Eureka moment. The smell of rain is not just about rain. It's about how your senses are tuned into a bigger web of signals. You are a receiver, constantly picking up chemical messages that most of the time you don't even notice. Petrichor is just one example of a much larger truth. The world is always whispering to you in molecules, from the ripening of fruit to the presence of fire to the arrival of a storm. Understanding that helps you see your place in the ecosystem not as a passive bystander, but as an active participant in an ancient conversation. So the next time someone says, "I think it's about to rain, I can smell it," you'll know the science behind that instinct. You'll know that soil bacteria, ozone, aerosols, and plant oils are working together to create that signal. You'll understand why it sometimes arrives before the storm, carried by downdrafts and winds. And you'll appreciate how your own brain, with its extraordinary sensitivity to geosmin, has been shaped by countless generations who relied on this exact skill to survive. That realization is powerful. It connects you not just to weather, but to history, biology, and the shared human experience. And maybe most importantly, it sparks a sense of wonder. Because the more we look closely at everyday things, whether it's the color of the sky, the shape of a flame, or the smell of rain, the more we see that there are no ordinary experiences. Every detail hides a story of physics, chemistry, and life itself. Science isn't just in textbooks, it's in every breath you take. So here's my challenge to you. Next time you smell that earthy perfume drifting on the wind, don't just think, "Oh, rain's coming." Instead, remember the bacteria beneath your feet, the invisible molecules dancing in the air, the electrical storms forming overhead, and your own brain interpreting it all in an instant. That's not just weather, it's a window into how the world actually works. If you enjoyed this journey and want more keys to unlock the hidden workings of our universe, don't forget to like this video, share it with a curious friend, and subscribe to How It Actually Works. Because the world is full of mysteries hiding in plain sight, and together we'll keep cracking them open, one story at a time.